All right, so our objective for today, I can add and subtract polynomials, read together, 1, 2, 3. I can add and subtract polynomials. So we already did a lot of combining like terms. So today's going to be like a recap. You don't need a Freire model or steps. You already have them. And today's going to be more like practice to clarify some doubts, number one. And number two, so that we can get through with addition and subtraction, okay? So with that said, so last week we had an essential question that read, what happens to the exponents to the variables, the variables of like terms? Elaborate. So we'll revisit that at the end. We also had a Freire model, and we know now what polynomials are, right? Or monomials or some indifference of monomials. We gave examples, non-examples. We wrote down our steps. Our steps were to distribute first the factors into the parentheses, identify like terms, use commutative and associative property to do that, and then simplify. So last week we did an introduction using the pet shop. Remember that? That we sold dogs, cats, dolphins, and so on and so forth. So where I want to clarify, though, is when we get to addition and subtraction. So pens down, eyes up here. So one clarification that I want to make, because tomorrow we're going to get into multiplication of polynomials, and tomorrow we're going to combine all the properties from multiplication, division, and addition and subtraction. And from tomorrow and on, this is where some of your noodles are going to start playing tricks on you, and you're going to be making simple mistakes because of the different properties. But that's why I want to clarify before we get there. Here it goes. So when we got to multiplication, bless you, multiplication properties of exponents, we did something like this, x to the fifth over x to the third. And for division, oh my bad, that one goes down here. That's division. My goodness. That's division. For multiplication, we did something like this, x to the seventh times x to the fifth, okay? So what did we find out? If they have the same base for multiplication, what happens? We find the sum of the exponents. And what happens when we're dividing? So this is, we add the exponents, over here we subtract, okay? But for addition, when we combine like terms, what did we find out? So let's say we went from here and here. These are the same like terms. What do they have alike? The x squared. And then what did we work with? Only the coefficients, 8 and negative 5. That's positive 3. Same here. This is a like term. What do they have alike? The x. And what do? We focus on the coefficients. This is 10. And then at the end, we work with constants. And then we end up with 23, Michael Jordan. So what did we notice? Did we do anything to the exponents once we add or subtract? No. We just focused on what? On the coefficients. Does everybody see that? When we multiplied and divide, we did do stuff to the exponents. When we add and subtract, we don't. Are we there? Because tomorrow I'm going to combine all of these in one. And I just want to make sure that your noodle is getting this straight. When we multiply or divide, we do stuff with exponents. When we add and subtract, we don't. Tell me never what I just said, please. Okay? So, now that we got that clear, last week we did some practice, and we did something like this. We started with tiles, remember that? From there, I gave you guys a different one, and from there, we combined both of them. And we used tiles to use combining like terms. So for today, we're going to do some practice. We already did some of them, but let me do some more. So look at this one. You don't have to copy this. Just pay attention. Let me zoom in. So like this one, just to emphasize the properties that we use. I start with this. Is there another like term, this one? Yes, down here, it's got the same variable, so therefore I write these together just to show the property. What is the property that I use when I move stuff around? Commutative. So here I just brought this one down. This is the commutative property of addition. All right? And from there, now we can group and simplify. These are the same variable, that's p cubed, and I focus on the coefficient. 12 plus 8, that's 20, and I just bring this one down, and that's 11p squared. Can we combine again? No, because they have totally different exponents on the variable. So we're done up to right here. So far, so good? Let me go over this one. Oh, and by the way, when we group them, what is the property there? Associative property of addition. Okay? B. Let's see. X squared. Do we have another x squared? No, so I just bring this one down, 5x squared. What's the next degree after 2? Look, on descending order, what is it? 1, which is this one. Is there another x? No, I just bring that one down, negative 3x. And my constants are right here, negative 6 and positive 8. That gives us plus 2. And we're done. So far, so good? All right, so on your screen, I'm going to send you a problem so you can do this on your iPad. You don't need to copy these on your paper. See how you do with that one. Lock your toolbar. Is it example 1, C and D? Okay. Copy that. See if you can do that by yourself. Go. And let me push the screen to you. See if you agree with this answer. And if you agree. Yes. Well, what's that? Both of them. Do you guys disagree with any of them? Yeah. No? Boss? No? Sergio? Say that again? What do you mean? Oh, I see. So you're saying that for, let me zoom in. Hold on. So you're saying that for this one, that to put ones here, like this, that's fine. But in this case, all we're saying is that are all these the same or like terms? Same variable, same exponent, same here, same here. So if you notice, they just focused on the coefficients. What is 10 plus 4? 14 minus 8, and that gives us 6m squared n. Okay? And on this one, some of you wrote it as negative 3t squared plus 1s squared. I'll take that, but if you remember, what did I say? Should write it if they have the same degree in alphabetical, right? So try and keep it organized. So far, so good? All right, let's do another one. Here we go. All right, let's look at this one. For these, I remember I said, this is example 2A. You don't have to copy this. Just pay attention. I said, since the coefficient here is 1 and 1, when we just multiply these out, we end up with the same thing. Is that correct? So therefore, we start by circling the first term. Is there another m squared? Yeah, right here. So that becomes 5m squared. From there, I go with this next one, which is m. Is there another m? No, I bring that down. And then my constant is 5 plus 6, that's 11. Remember those? Yeah? Fairly simple? All right, so with that said, on your screen, do this next one, please. It's example 2C. 2C. Copy that. So if you notice on this one, they went ahead and highlighted all the like terms. And once again, they just wrote x squared, and they focused on the coefficient 6 plus 3 minus 2, and minus 8. That gives us 1x squared. And then also these y, and then we got negative 4, negative 2. That's negative 6 plus 3. That's negative 3. Okay, hands if you got that. Okay, good. So let's continue. So now that we got addition down, right? Now we went into subtraction. Remember that I did a brief intro? Okay, so let me go to that. So copy this one, example 2D, and it says parentheses 1/2 a squared plus b plus 2, close parentheses, plus, open parentheses, 3/2 a squared minus 4b plus 5. Do that one by yourself. Go. Okay. So, that was this one. Let's see, help me out with this one, please. Cedric. Oh, no, he's not here. My bad. Sorry. Sebastian, what'd you get for this one? Okay, hold on. You said 2a squared. Oh, it's rolling. Let it go. 2a squared minus 3b plus 7. Hands if you got that? That is correct. Now, if you notice, we've been doing addition horizontally, right? But how did I introduce it when we first started? Remember the pet shop that I said I'm going to call you and give you orders, and which way did I add? Vertically, right? You can do it either way. So let me show you this one vertically. Watch. Look up. Let me zoom out. Okay, so I'm going to use only this one right here. If I was to place this underneath here, no longer here, therefore, 5 plus 2, 7, negative 4 plus 1, negative 3b, 3/2 plus 1/2, that's 4/2, a squared, and we can simplify this to 2a squared minus 3b plus 7. Did you ever see what I did? Yes. What do you mean? Oh, here? If the denominators are not the same, then you need to find a common denominator if it has different fractions on the same variable. Okay? So I'm going to give you another one for you to do on your iPad, which is this one, and I want you to do it vertically, not horizontally as we were doing it. Does everybody understand? So basically, I want you guys to align it like this and find the sum, and I'm going to send this to your screen. Here we go. So copy that and do that one by yourself. All right. About Francisco, what'd you get? What is it? Okay. Sergio, what'd you get? Hands if you got that. Looks about right. Now, there's two ways of doing this. You could have just written this underneath where you can combine, or you can combine first these, the a squares, right? Write it out, and then bring these over. So either way is correct, okay? Oh, you guys are saying, oh, my bad. Sorry. There you go. So, like I said, you could, couple ways that you can do this. You can combine the a squares first, write it out, 5a cubed plus 15a squared minus 6a, and then just bring this over, 7a cubed, and then negative 10a, and then just simplify to that. Okay? All right. So we're done with addition. Let's go to subtraction. So watch. So for subtraction, I remember when I introduced this, I didn't give you this one, I gave you this one right here. Remember that? And we said that for these, let me zoom in. For these, start with this second paren, and the coefficient here is -1. Therefore, -1 distributes to each of the terms, so this becomes -5m to the fourth. This becomes positive 5m squared. -1 times 8, that's -8. The coefficient here is a 1, therefore, when we distribute, we're left with 7m to the fourth minus 2m squared. Remember that? All right, so then from there, we know what to do. Is that correct? So 7m to the fourth, -5m to the fourth becomes 2m to the fourth. From there, -2m squared plus 5m squared becomes positive 3m squared. And then just bring the constant down, which is -8. Does everybody remember why this is called the constant? Think about it. Why is this one called the constant? Think about it first. See if you can remember. Hopefully your teachers cover that. If not, I'll cover it right now. Talk it over with your neighbor. Why is this called the constant? See if you remember. Okay, here it goes. Really quick, before we move on to do more subtraction, look up, please. This is called a constant because of this. If I was to say, okay, guys, I need you to evaluate this expression, which means simplify it once I give you a value for the variable, and I said m is equal to 2. So then instead of m, what am I going to write here? 2 to the fourth power. 2 to the fourth power, that's 2 times 2 times 2 times 2, which is 16. Times 2, that's what? 32. And this one is 2 squared, that's 4 times 3, that's 12. Which is the only one that stays constant? -8. That's why it's called a constant, because the value doesn't vary, because these vary because they have a what? Variable. Everybody got it? So with that said, since we already know subtraction, I just wanted to recap on that. I want you to do this one. It's example 3C. And I'm going to push this to your screen really quick. Copy that. As you're finishing up really quick, the coefficient here is a -1. Is that correct? Right here. Sorry. Coefficient here is -1. We distribute. This becomes -x squared minus x minus 1. This one stays the same, 2x squared minus 3x squared plus 1. Therefore, 2x squared and -1x squared becomes x squared. And we have one more x squared. Is that correct? So that is, that is -2x squared. And then the x comes down, -x, and then 1 and -1 cancel, so therefore, -2x squared minus x. Okay? All right, before you close your iPads. All right. Really quick. How comfortable do you feel with these adding and subtracting polynomials so far? Copy that. Once again, your home plate for tonight. Page 498, home plate. Good one, everyone. Do your home plate. See you guys tomorrow.